You're paying $60, sometimes over $120 a month for water. That still isn't truly clean. Not fully, not completely, because even after treatment, what reaches your glass can still carry chlorine byproducts, trace metals, and chemical residues. Your system never fully removed. And the most dangerous part is this: you don't notice it, because you've been trained not to question it. Now here's the part that should stop you. There are families in the United States right now drinking water for less than $2 a month. Using a system so simple, most people would dismiss it at first glance. No electricity, no filters to replace, no monthly cost quietly stacking up year after year. And yet, the water they drink is cleaner in key ways than what most people are paying for. So the real question isn't whether clean water exists, you already have access to it. The question is, why are you still paying for something you don't fully trust when a better option might already be within your reach? In this video, I'm going to break this down for you, step by step, so you can see exactly how it works. And more importantly, what most people are missing, because what makes this system work isn't what you think. I remember walking into that house expecting to find some kind of expensive setup hidden in the basement, something complicated, something engineered, something that would justify the kind of results I had just been told about. But what I saw instead stopped me cold. It wasn't a machine. It wasn't a system lined with pipes and gauges. It was a simple wooden barrel sitting quietly in the corner, next to a shelf of everyday tools, the kind of place you wouldn't look twice at if you didn't know what you were looking for. The air smelled clean, not chemically clean, just neutral, almost like being outside after a light rain. The man of the house noticed where I was looking, smiled, and pointed directly at it. That's it. He said, no hesitation, no explanation, just certainty. And I'll be honest with you, I didn't believe him. Not at first, because you're conditioned, just like I was, to expect that anything truly effective has to be complicated, expensive, or hidden behind some kind of system you don't fully understand. Then his mother walked into the kitchen, filled a glass from a small spigot connected to that barrel, and handed it to me. The water was cold, clear, no smell, no metallic edge, no chemical aftertaste. I took a sip, expecting something, anything, but there was nothing there except water in its purest form. And that's when it hit me. I couldn't remember the last time water tasted like this, so I asked the only question that mattered: where does it come from? She looked at me like the answer should have been obvious, and said, from the rain. And that's when I realized this wasn't just water. The moment you step back and really look at it, the system almost feels too simple to be taken seriously. No wires, no humming equipment, no cartridges to replace every few months, just a container, a few natural materials, and gravity doing exactly what it has always done. And that's the part that challenges everything you've been conditioned to believe, because you've been taught subtly over time that anything effective has to be complex, regulated, and expensive. But this system doesn't follow those rules. It's been around for decades, in some cases generations, quietly working in the background without upgrades, without subscriptions, without needing constant maintenance. Families built it once and kept using it. Not because they were trying to avoid modern solutions, but because this already worked. And not just worked in theory, worked every single day, producing water that people actually preferred to drink. When you strip it down to its core, it's not revolutionary technology. It's controlled flow, natural filtration, and time. That's it. No pressure systems forcing water through membranes, no electricity accelerating the process. Just a slow, deliberate method that lets each layer do its job the way it was meant to. And the more you think about it, the more uncomfortable the question becomes: if something this simple can work this well, why did we move so far away from it in the first place? Because simplicity is exactly what most people don't trust anyway. When you finally break the system down, what looks almost too simple at first starts to reveal a level of precision most people completely overlook. It's not random. It's not guesswork. It's a sequence, 4 distinct layers, each one doing a specific job, each one correcting a different problem that exists in raw water. And once you understand what each layer actually does, you stop seeing a barrel and you start seeing a system engineered by experience. The first layer sits right at the top, coarse sand. This is your front line, the barrier that handles everything your eyes can see. Leaves, debris, bits of dust, anything carried in from a roof or collection surface gets caught here before it ever moves deeper into the system. It's not sophisticated, and it doesn't need to be. Its job is simple. Stop the obvious contaminants before they interfere with everything below it, and if this layer fails, the rest of the system gets overwhelmed. Below that sits the second layer, fine sand. This is where things start to get more precise, because now you're dealing with what you can't see, tiny suspended particles. Sealed, microscopic debris that floats through water unnoticed. Fine sand slows the flow just enough to trap those particles, forcing water to move carefully, not quickly, and that's a critical shift, because fast filtration feels efficient, but it usually means things are slipping through. Then you reach the third layer, and this is where the system changes completely. Activated charcoal, also known as biochar, doesn't just filter, it absorbs. Its surface is filled with millions of microscopic pores, each one capable of trapping chemicals, binding heavy metals, and reducing compounds like chlorine and pesticides that give water that sharp, artificial taste. This isn't just mechanical filtration anymore. This is chemical interaction at a molecular level, but one layer does most of the work. And it's this one, because without it, the water might look clean, but it wouldn't taste clean. And it definitely wouldn't be as safe. This is the layer that transforms the water in a way you can actually feel. And finally, at the base of the system, there's crushed limestone or gravel. At first glance, it seems like it's just there to support everything above it. But it's doing something subtle and important. Rainwater is naturally slightly acidic, and as it passes through this layer, the limestone gently raises the pH, balancing the water and removing that flat, acidic edge. Most people don't even realize they're tasting. So what you're left with is not one single filter, but a sequence each layer correcting what the previous one couldn't. Physical debris, microscopic particles, chemical contaminants, and even the balance of the water itself. And together, they turn something raw into something almost unrecognizable. At this point, you might be thinking, this sounds convincing, but you still want to know if it actually holds up beyond anecdotal stories. And that's exactly where this gets interesting, because the core of this system, biochar, or activated charcoal, isn't just some rural workaround. It's one of the most studied natural filtration materials in the world. When you look at it under a microscope, what you see is not a solid surface, but a complex network of microscopic pores creating an enormous surface area inside a very small piece of material. And that's what makes it powerful, because when water passes through it, contaminants don't just get filtered out, they get captured, bonded, and held in place at a molecular level. Researchers have documented how activated carbon can reduce chlorine, absorb organic compounds, and significantly lower concentrations of certain heavy metals. This is the same principle used in many modern filtration systems, just scaled up, packaged, and sold back to you in cartridges that need constant replacement. What's different here isn't the science, it's the simplicity of how it's applied, and it doesn't stop there. Variations of biochar filtration have been used for thousands of years, from ancient agricultural systems in the Amazon basin to modern-day water treatment research. The principle hasn't changed. Only the packaging has. So when you see this system working, you're not witnessing a hack or a shortcut. You're seeing a fundamental process that has been understood, tested, and quietly relied on for generations. So this isn't a trick. It's something we've known for a very long time. If something this simple, this effective, and this well understood has been around for so long, the obvious question becomes, why haven't you heard about it before? And this is where things stop being purely technical and start becoming a little harder to explain in a straight line. Because when you go back and look through older agricultural records, extension pamphlets, and rural sanitation guides from the early to mid-1900s, systems like this weren't unusual. They were documented, taught, passed around freely, especially in communities that didn't have access to centralized water infrastructure. But over time, those materials became harder to find, not because they were officially removed, at least not in any clear or direct way, but because they were slowly replaced. New systems came in, municipal water expanded, filtration became something you purchased instead of something you built. And as that shift happened, the older methods didn't disappear overnight. They just stopped being talked about. And when something stops being part of everyday conversation, it doesn't take long before it feels like it never existed in the first place. Not erased, not banned, just left behind as attention moved somewhere else. And maybe the reason isn't that it was hidden, but that it was simply forgotten. So if you wanted to build this yourself, the process is far more straightforward than most people expect. But that doesn't mean you can rush it or improvise without understanding what actually matters. You start with a container, something like a 5-gallon food-grade barrel, or even a smaller setup if you're testing this on a household scale. Near the bottom, you install a simple spigot so you can draw water after it has passed through the system. From there, everything is about how you layer the materials and how the water is allowed to move. At the base, you place a few inches of crushed limestone or gravel. This creates a stable foundation and supports the structure above while also helping balance the pH of the water. Above that, you add your activated charcoal layer. This is the core of the system, and it needs enough depth to allow proper contact time as water passes through. Then comes the fine sand, packed evenly to slow the flow and capture suspended particles. Finally, the top layer is coarse sand, acting as the first barrier against visible debris. Water is introduced at the top and moves downward through each layer by gravity alone. There are no pumps forcing it through, no pressure accelerating the process. And that's critical, because the effectiveness of this system depends on time and contact, not speed. You're not trying to push water through, you're letting each layer interact with it, gradually refining it as it moves. If it flows too fast, it's not working. And that's where most people unknowingly get it wrong. Here's where most people make a mistake that quietly ruins the entire system before it even has a chance to work. And it starts the moment rain hits your roof, because what you're collecting in those first few minutes isn't clean water. It's a concentrated wash of everything that's been sitting up there since the last storm dust, pollen, bird droppings, microscopic debris, even residues you didn't know were there. And if you let that water go straight into your filter, you're not purifying it, you're feeding contamination directly into the system you're trying to protect. This is why experienced builders never skip what's called a first flush divert. It's not complicated, it's not expensive, but it's absolutely critical. The idea is simple. You divert and discard the first portion of rainwater before anything reaches your storage or filtration setup. That initial surge fills a separate vertical pipe, isolating the dirtiest water and keeping it out of your system. Only after that section is full does cleaner rainwater begin flowing into your filter. Without this step, your layers clog faster, your charcoal loses effectiveness, and the water quality drops in ways you won't immediately see, but you will eventually taste. And by the time you notice, the damage is already done. This one step changes everything. Now, you might be thinking this only works if you're living off-grid, collecting rainwater and building out a full system from scratch. But that's not the case. Because the same principle can be scaled down into something you can set up in a single afternoon, without touching your plumbing, without permits, and without changing anything about how your home currently works. All you need are 2 standard 5-gallon food-grade buckets. The top bucket becomes your filter chamber. The bottom one becomes your clean water reservoir. You drill a small series of holes in the bottom of the top bucket, stack it above the second, and install a simple spigot near the base of the lower bucket. Then you recreate the same layered structure gravel at the bottom, activated charcoal above it, followed by fine sand, and finally coarse sand at the top. You pour water into the upper bucket, and gravity takes over. It moves slowly, intentionally, through each layer, collecting below where you can draw it out as needed. No electricity, no pressure systems, no complicated installation, just a controlled, repeatable process you can manage yourself, which means this isn't just for off-grid living. It's for anyone. Now here's the part. Most guides skip, and it's where a lot of well-intentioned setups quietly turn into a problem you didn't plan for. The moment you start storing water, especially in warm climates, you're creating an environment that can support life. You don't want bacteria growth, algae, and most importantly, mosquito larvae. And this isn't theoretical. Standing water is one of the most common breeding grounds for mosquitoes. And in parts of the U.S., that comes with real health risks. So even if your filtration is working perfectly, what happens after the water is stored can undo everything you just built. This is why experienced systems include one simple but overlooked addition: fine copper mesh placed over every opening intake points, overflow lines, and any exposed surfaces, not aluminum, not plastic, copper, because when water comes into contact with copper, it releases trace ions that are naturally hostile to microorganisms and larvae, disrupting their ability to survive and multiply. It's not a chemical treatment. It's a passive, continuous form of protection built into the system itself. So you're not just filtering water, you're controlling what can grow in it afterward. Because clean water isn't just about what you remove, but what you prevent. Up to this point, everything you've seen is about removing what shouldn't be there: particles, chemicals, contaminants you can measure. But there's one final layer most people never even consider because you can't see it working, and you can't taste it when it's missing. This is where the system moves from effective to complete. Once your water has passed through the filtration layers, you don't drink it right away. Instead, you pour it into clear glass bottles filled completely, sealed tight, no air gap, and you place them outside in direct sunlight. Not in the shade, not behind tinted glass, full exposure, the kind of sunlight that heats surfaces and forces you to squint. You lay those bottles on their side, ideally on something reflective like corrugated metal. So light hits them from above and below. Then you wait 6 to 8 hours. No shortcuts. What's happening during that time isn't visible, but it's precise. Ultraviolet radiation, UVA and UVB, passes through the glass and penetrates the water, disrupting the DNA of microorganisms that may have survived filtration. Bacteria. What is this? Residual biological threats. They lose their ability to reproduce. They become inactive, harmless. It's the same fundamental principle used in high-end UV sterilization systems, just stripped down to its most basic form: sunlight, glass, and time. And when you pick up that bottle at the end of the day, you're not just holding filtered water. You're holding water that has been physically cleaned, chemically refined, and biologically neutralized in sequence. And after that, what you're left with is something surprisingly close to pure. Now, when you step back and look at the entire system as a whole, it stops feeling like a collection of simple steps and starts to reveal a deeper logic, each part solving a different problem in sequence. The filtration layers handle what you can measure: debris, particles, chemicals, and imbalances in the water itself. That's the physical and chemical side of the equation. Then the solar finishing step takes over, addressing what filtration alone can't fully guarantee: biological safety. So instead of relying on one method to do everything, you're stacking processes, each one doing exactly what it's designed to do, without overlap, without shortcuts. Water moves through stages, becoming progressively cleaner at every step, until there's nothing left to correct. This isn't about complexity. It's about alignment, letting simple processes work together instead of forcing one system to carry the entire burden. Not one method, but layers working together. At some point, without ever being told directly, you were taught that water is something you buy, something that comes with a label, a system, a monthly cost attached to it, and over time, that idea becomes normal. You stop questioning it, you stop asking where it comes from or how it's treated, because you assume the answer is handled somewhere beyond your control. But at the same time, you're also taught something else quietly, indirectly, that anything simple, anything free, anything you can build yourself can't possibly be as good. So you trust the bottle, you trust the system, and you doubt the alternatives before you even try to understand them. But when you actually see how this works, when you follow each step and understand the logic behind it, something shifts, not in the water, but in you. The real shift wasn't in the water. It was in how we learned to see it. So now I want to ask you something directly if you had to choose today. What would you trust more, the water you've been paying for your entire life, or a system you can actually understand and control yourself. Because this isn't just about filtration. It's about how much of your daily life you've handed over without ever seeing how it works. And once you start questioning one thing, it doesn't stop there. Tell me in the comments, would you actually try something like this in your own home? Or does it still feel too simple to trust? I read every response, and I want to know where you stand. And in the next video, I'm going to show you another system built on the same principle, one that heats an entire home without electricity, gas, or monthly bills. And once you see it, it's hard to unsee.